Let's do question 5c, which is the last part of our question 5. Given f of x is equal to negative 1 over 3x cubed plus x squared plus 3x plus 1. For what values of x is the function increasing? Okay, before we do this, I want us to discuss the shape of a cubic graph. Okay, right, this is the cubic function f of x, the general form of what? Of a cubic function, right? Ax squared, ax cubed plus bx squared plus cx plus d. Okay, that's the general form for a cubic function, right? We have to know that if a is greater than 0, if a is positive, what will be the shape of the graph? How will the graph look like? So if a is greater than 0, the graph is going to be shaped like this. I just know that the last part is pointing upwards. If a is greater than 0, the last part of the graph is pointing upwards. And then if a is greater than 0, this is how the graph is shaped. And then if a is less than 0, meaning that if a is negative, then the graph is going to be shaped like this. You see that the last part there is pointing downwards. Okay, right. And then now, if we check our function, we are saying here f of x is equal to negative 1 over 3 x cubed plus x squared plus 3x plus 1. So meaning that it means our a is negative, meaning that our graph is shaped like this. Let me draw here a bigger one, meaning that our graph is shaped like this. I'm going to use this bigger graph to explain. This is how the graph is shaped, since our a is negative. Okay, and then where is the graph increasing? Where is the function increasing? So it means between the turning points. Between the turning points. This will be the turning point here, and then this is the turning point. Okay, you see that? So now this is the turning point. This is where the graph is increasing, is going up. So what do we need to do here? It says for what values of x is the function increasing? We have to find the x values of the turning points. And then how do we do that? We derive and equate the derivative to 0. Remember, the derivative is the gradient. And then at the turning points, the gradient or the gradients are equal to 0. At the turning point, the gradient is equal to 0. Okay, so now we have to derive our function, get the derivative and equate it to 0. And then after that, we find the x coordinates of those turning points. Right, let's do the differentiation. Right, so f prime x, which is the derivative, we're going to say 3 times negative 1 over 3 is going to be negative 1. Okay, so it's negative 1. I won't write the 1, just negative. Then x, then 3 minus 1 is going to be 2. Right? We go to 2 times 1 because there's an invisible 1 here. 2 times positive 1 is going to be 2. It is 2. And then x, and then 2 minus 1 is 1. So there's a 1 here. We don't write it. And then we come to the third term plus, because there's a positive there. 1 times 3 is 3. And then x to the power 1 minus 1 is 0. 1 minus 1 is 0. So x to the power 0 is 1. And then we're remaining with 3. And then the derivative of a constant is equals to 0. So now we have derived. So now at the turning points, the derivative is equals to 0. And then negative x squared plus 2x plus 3. Okay, right? And then we can divide everything by -1 so that we get 0 is equals to x squared minus 2x minus 3. Right, and then we can use factorization here. Okay, factorization. I'm not going to explain that. I assume that you know how to factorize. Maybe you can use the quadratic formula if factorization is giving you problems, but it's very easy to factorize here. We're looking for the factors of -3. That will give us -2 if we add them. So that will be -3 plus 2, because this shows us, this negative here, this one, shows us that one factor is negative and then the other factor is positive. And then this negative here shows us that the bigger factor is the one which is negative. So it means it's -3 and +1. So it means 0 is equals to x. We said -3 is -3 and then +1. We have factorized them. So meaning that x minus 3 is equal to 0, or x plus 1 is equal to 0. Therefore, let me start with the smaller one. It's going to be x is equal to -1, or x is equal to 3. So this is where so these are the x coordinates of the turning point. So it means here x is equal to -1. So I'll just write -1 here. And then x here is 3. These are the x coordinates of the turning points. And then between these x values, this is where the graph is what? Is increasing. It's an interval here. So it means x is greater than -1 but less than 3. Okay, this is where the graph is increasing. We cannot include the -1 and 3. Why? Because when x is -1, the graph is not increasing. It's actually the gradient there is 0 at the turning point. Even at 3 there, the gradient is 0 at the turning point. So we don't include -1 and 3. So that is the answer there. Where, for what values of x is the function increasing? When x is greater than -1 but less than 3. That's the answer for our question. We have done all the questions for question 5. So we're going to meet when we're doing question 6. Goodbye.